Okay, this video is going to start off with 10.7. 10.7 will be broken down into 3 separate videos. This is going to be special segments of circles that deal with chords. We need to remember that in a in a circle, a chord is a line segment with 2 endpoints on the circle. As I tell my students, because I have a lot of students confusing secant and chord, because they look a lot alike, and you have a chord within a secant. Your chord is like an extension cord. There are 2 ends to the extension cord, and so that's what we have here. This is a diagram of having one single chord in the circle, and then here we've got a diagram of 2 chords, and the last one, the third one, is showing several chords. So we're letting you know at the below this that there is no limit to the number of chords inside of a circle. So we're going to look how many circles can we count in the third circle above. This one right here says several. Well, here I'm seeing, okay, I've got a chord right here. Got AC, there's 1. I've got AD, 2, AB, 3. Okay, so those are the 3 coming out of A. And then we have another one here from C to D, and another one from C to B. So we have a total of 1, 2, 3, 4, 5 chords. And the next question, or the next thing is saying 2 chords inside a circle must always intersect. Does every 2 chords have to intersect? True or false? This is going to be false. As we see up here, chord AC, that segment right there, doesn't intersect any of the other ones. They do not have to intersect. So down here we talk a little bit, repeat it again, they do not have to intersect, but when they do, this is what they could look like, something of this nature. So we're going to go ahead and name the 2 chords here. We have segment AB, remember a chord is named as a segment with our segment bar above it, and the other chord, segment CD. What ends up happening when you have these 2 chords intersect, we're going to end up with 4 smaller parts. And I want you to know that word parts, that's where our formula is going to come from. Okay, so we're going to see these 4 different parts, and we're going to go ahead and name these parts. If we start with segment AB, we're going to see that segment AB has been split into segment AE and segment EB. So that is going to be 2 of the parts, AE and then EB. Then we check out segment CD. It has been split into segment CE and segment ED. Using these 4 parts, we'll go ahead and look at our formula. The formula is simple as this. You're going to take the 2 parts of one chord, so in this case it would be AE and EB, and we're going to multiply them together. So we call this is just part times part. And that's what it says here. It's going to be the products of their parts are equal. So we're going to take the product of the one chord over here, AB, its parts, AE times EB. This will be equal to the product of the other chord's 2 parts, CE times ED. So simply just part times part equals part times part. Now, when we start looking at the problems, you have to keep the parts together that are on the same chord. You cannot just start switching them around. So let's take a look at what this is going to look like. We have a total of 4 examples of this. Some starting off with just simple algebra and then going into more extensive algebra. So here, using the formula, we're going to go ahead and find the value of x, for example, number 1. So I'm going to go ahead and break this into 2 different colors. We're going to go ahead and take, it doesn't matter which chord we start with, but we want these 2 parts together. This part of x times the other part of that same exact chord times 15. This will be equal to the other chord's 2 parts, the 9 times the 5. Again, making sure that you're seeing the parts of the same chord are on the same side of the equal sign. So this breaks down to 15x, once we do the products, equals 45. When we divide by 15, we're going to find that x is 3. So we'll go ahead and move on to example 2 using the same fashion. Okay, we're going to take part times part of one chord. Here I'm going to take the x times the 4. 2 parts on the same chord. This will be equal to the 2 parts on the other chord. 5 times 8. We'll go ahead and multiply. We're going to end up with 4x equals 40. And a lot of us could probably already see, when we divide by 4, x will be 10. What I encourage you to do is pause the video and see if you can set up example 3 on your own. I know we have an x plus 2, but at least see if we can put the correct things in the correct parentheses. So here, I already know where the x, I like to put, the x kind of in the first place here. I'm going to go ahead and take this part of 15, because I already know I'm going to have to do some distribution. We're going to multiply this by the other part of that same chord, x plus 2. We're going to set this equal to part of the other chord, 10, times the second part of the other chord, 24. As we come down to solve, we need to make sure that we are distributing over here 15 times x, and then 15 times a plus 2 plus 30. On the other side, anything times 10, just add a 0 to it. So we add a 0 to 24, we have 240. Go ahead and pause the video and solve the rest of it on your own. We only have 2 steps left. Our final answer should have been 14. All right, last one. Let's go ahead and take a look. What I'm noticing with both these chords, when I multiply, I'm going to end up having to distribute. So I'm going to go ahead and with the chord that goes from the top left to the bottom right, I'm going to go ahead and start off putting the 21 first, just so I have my distribution set up a little better. 21 times the x minus 5. And if you started with the other chord, there is absolutely no problem with that. We set this equal to, on the other chord, we have 24 times x minus 9. So we do have to distribute on both sides of this. Let's go ahead and start off here. 21 times x, giving me 21x. 21 times negative 5 gives me negative 105. Distribute on the other side, 24 times x, 24x. 24 times negative 9 gives me negative 216. All right, so let's start moving some things around here. We're going to go ahead and start by, I've got my variables on both sides. I'm going to move my smaller variable by subtracting 21x from both sides. When I do this, please remember there is a negative 105 that we are bringing down. I notice a lot of my students are really good at noticing that. 24 minus 21, we're left with 3 x's minus 216. Don't worry, we won't have this negative number because we're going to take care of it now. Add 216 to both sides. And when we add, we take negative 105 and we add 216, we're going to get a positive 111. We just divide by 3. And x will come out to be 37. Okay, so with 2 chords, just that little x in the circle, part times part equals part times part. Making sure we're multiplying the same parts of the same chord, or not the same parts, but the parts of the same chord together.